This is video 2 for lesson 4 in unit 4 kinetics for chemistry 2. So in the last video we talked about the collision theory and the transition theory. So now we're going to start looking at two different diagrams, one for an exothermic reaction and one for an endothermic reaction. So this is the one for an exothermic reaction. So on the x-axis we have the progress of the reaction, so we have time, and we have the amount of energy. So we're going to start our reaction here. So let's use our A plus B2 that we had up here. So at the start of a reaction, by the chemical bonds that are present, we have a certain amount of energy that is contained, potential energy, within the chemicals. As the reaction progresses, and we have to add energy in to reach the transition state. So this peak up here is going to be this transition state, which is high energy, and it's enough energy to get our reaction started. And then for an exothermic reaction, we know that the net energy is lost. So this reaction is actually going to end up with lower energy than we started with. So this is a transition state up here. Down here we have our AB plus B. So we have our products. So there's three different things that we can look at here. If I were to draw a line at the top, here, and here at the end, if we look at the difference in energy between these three lines, this right here represents the energy that we had to add in to reach a transition state. So this is our activation energy. And sometimes that's abbreviated with capital E with a subscript of A, or E sub A. This right here represents our energy given off, which, using some terminology from last unit, we have a negative delta H. So this amount of energy from where we began and where we ended up is going to be given off. So we're lower than where we started. So let's look at an endothermic reaction on the next page. So same premise, we have A plus B2. We still are going to have to add energy in to this to reach the transition state. But where this one differs is where we end up. So here is our transition state. And now we end up higher than where we started. So if we draw our lines again, here, about there, and at the top, this right here is our positive delta H. So this is the energy absorbed by the reaction. Our activation energy is this whole thing here. So here is our E sub A. It includes the positive delta H. So that's how these two graphs are different. You should be able to look at these graphs and interpret and say whether something is exothermic or endothermic, what represents the activation energy, what kind of energy is given off or absorbed.